Hello, and welcome back to another Orange Coast College Mathematics video. In this video, we're going to talk about simplifying complex numbers. So, first off, what is an imaginary number? Well, it's actually going to be denoted I for imaginary, right? And it is the square root of -1. Now, just like any other square root, if we square something with a square root, we just get the number that's underneath it. So, I squared is equal to -1. Now, typically, we don't want to have square roots with negatives underneath them. So, we're going to follow this process. When we have the square root of a negative number, we're going to use our multiplication property and we're going to separate it as the square root of -1 times the square root of a positive number. Then we'll be able to replace our square root of -1 by I, and we'll have I times the square root of a positive number. And then we can simplify any more if we have to. So, let's go ahead and try this out on number 1. So, we have the square root of -3. Now, I want to write this in terms of I, so I don't want this negative inside of my square root. So let's go ahead and follow this process. I'm going to rewrite this as the square root of -1 times 3. Now we can separate this into the square root of -1 times the square root of 3. But we know that the square root of -1 is going to be denoted as I. So we write this as I times the square root of 3. Let's try it again with number 2. So we have the square root of -49. We follow our process. We have the square root of -1 times 49. And now we can separate this using our multiplication property. This becomes the square root of -1 times the square root of 49. Now the square root of 49 is going to be 7. So we have 7, and then square root of -1 is I. As a little caveat, whenever you have an integer and I multiplied together, you'll just have the integer out in front. But when you have a square root and I being multiplied together, typically you'll have I out in front. The reason we do this is because we don't want to accidentally include I inside of the square root, when we really meant to have it on the outside. And sometimes it's easy to mistakenly have the square root of 3 times I when you say, oh, is this I inside my square root or not? So by having the I in front of the square root, it just makes it less confusing, and there's no way that you're going to accidentally put the I underneath your square root when you didn't mean to. So moving on to our next problem, we have the square root of -12. We're just going to follow our normal process, and we have the square root of -1 times 12. We separate that into the square root of -1 times the square root of 12. And this is going to be I times the square root of 12. Now, technically that's not wrong, but we can simplify the square root of 12 further. I can break 12 down into 4 times 3. So this is going to be I times the square root of 4 times 3, which breaks down into I times the square root of 4 times the square root of 3. But what's the square root of 4? 2. So we get 2I times the square root of 3. And that's our final answer. Moving on to our next problem, we have negative square root of -45. So let's follow our process. We have negative square root of -1 times 45. Which then becomes negative square root of -1 times the square root of 45. Now we have the square root of -1, so that becomes I, but we have a negative sign out in front, so it's negative I. So this is negative I square root 45. However, we can break 45 down into a perfect square times something. So we can break this down into 9 times 5. So this is going to be negative I times the square root of 9 times 5. The square root of 9 is going to be 3. So this will be negative 3I times the square root of 5. Moving on, we're going to talk about what complex numbers are. A complex number is going to take the form a plus bi, where a and b are both just real numbers, and I is what we just learned is an imaginary number, is the square root of -1. Now, if b is equal to 0, then let's look at what happens. We have a plus 0 times I. So we've gotten rid of our imaginary part. So the only thing that's left is just a normal real number. Now if a is equal to 0, we've gotten rid of our real part and we're just left with a number times I, which is what we were going over in the previous problems. It's just an imaginary number. Now, if we have a plus bi, it's going to be said to be written in standard form. And finally, if we have a plus bi and a minus bi, those are called complex conjugates. You may be familiar with conjugates in terms of normal square roots, but now we have complex versions of it. So let's go ahead and try out a problem, and let's look at number 5. So for number 5, I want to rewrite this as a complex number. As in, I want to write it as a plus bi, a real part plus an imaginary part. So let's try to separate the imaginary part from the real part. So we have 5 plus the square root of negative 9 divided by 4. So we can separate this into two separate fractions, and this becomes 5/4 plus the square root of negative 9 divided by 4. Now I want a plus b times I. So I want to turn the square root of negative 9 divided by 4 into something that looks like a number times I. So I need to deal with this negative under the square root. So this becomes 5/4 plus the square root of negative 1 times the square root of 9, all divided by 4. Now the square root of negative 1 is I, but the square root of 9 is 3. So putting all of this together, we get 5/4 plus 3 times I divided by 4. Now this is fine, but we can make it look a little bit prettier and write it as 5/4 plus 3/4 times I. As in, this is a plus bi, so we have it in standard form. Let's move on to number 6 and do the same thing. So first off, let's go ahead and separate this. So we have 3/7 minus the square root of negative 32 divided by 7. Now I want an I on this right portion, so let's go ahead and separate our square root. This becomes 3/7 minus the square root of negative 1 times 32 divided by 7, which then becomes 3/7 minus I times the square root of 32 divided by 7. However, we can break down 32 into a perfect square times a number, because 32 is 16 times 2. So we can rewrite this as 3/7 minus the square root of 16 times 2 divided by 7 times I. But what is the square root of 16? The square root of 16 is 4. So our final answer is going to be 3/7 minus 4 times the square root of 2 divided by 7 times I. Since we have it in a plus b times I, this is in standard form. Moving on to our last problem, we have 4 plus or minus the square root of negative 24 divided by 2. Let's try to put it in standard form. So let's go ahead and separate it. So we have 4 divided by 2 plus or minus the square root of negative 24 divided by 2, which then becomes 2 plus or minus the square root of negative 24 divided by 2. But let's go ahead and break that down. The square root of negative 24, I can write it as negative 1 times, and we know that we're going to have to try and break down 24, so let's just do that all at once. What is 24 in terms of a perfect square times a number? Well, 6 times 4, 4 is a perfect square, so we can write this as 4 times 6, and then all of that divided by 2. So this will break apart into the square root of negative 1 times the square root of 4 times the square root of 6. The square root of negative 1 is going to be an I, the square root of 4 is going to be a 2, and the square root of 6 is just going to be square root of 6 because we can't break it down any further. So this becomes 2 plus or minus 2 times the square root of 6 divided by 2 and then times I. But we have a 2 in the numerator and in the denominator, so those are going to cancel out. And we get a final answer of 2 plus or minus I times the square root of 6. That's going to do it for this video, and I hope to see you in the next one.